Okay, more examples now under different conditions. Let's change a chemical instead of silver plus, zinc, 2 plus. Okay, with ammonia, instead of complex with 2, you can complex as many as 4. So how do you know that? You know, the table, the complexation, the K table going to give you 4. Yes.
What is the charge on that complex?
2 plus.
Oh, thank you.
Ammonia is neutral.
Right, but it was the way you wrote it, sorry.
No, that's fine. It's a little weird. Yeah. Okay, so 4 is the highest. And therefore, you will need 4 KFs values. So look at each one specifically. So the first complex, you will have a corresponding KF1. And later on, we will call this capital letter B1. B1 for simplicity, you know, coding and code simplicity later. Now you get so many alpha, beta, and capital B. This is a simple thing. Okay, now the first one. The first complex can add another ammonia, then form the second one, is KF2. So now, be sure you know the difference. You know, KF2 is specific for the first complex, react with one more ammonia, is called KF2. Okay? Sometimes it's confusing, right? Some people could think that KF2 refers from this one, react with 2 ammonia. So that is not right. So KF2 is specifically after the first complex with ammonia. It's KF2. Okay, then KF3 is specifically after the second complex and another ammonia. Okay, then KF4 is so on and so forth, specific for this reaction. Okay, so now you know some more complicated expression. So what if you multiply KF1 and KF2? What does that mean? Okay, so the meaning independently, KF1 is this one. Independently, KF2 is this one. So you can cancel the intermediates, right? Cancel it, then you end up with this over that. So this expression can translate into this, right? So this is a product over reactants. So reactants is this to form that. So now, what it means is, if you look at this 2 and go all the way to 2, complex 2, then that needs to multiply KF1 and KF2. Right? So that's why I told you earlier, be careful that KF2 alone does not mean is this guy react with this guy all the way to that. Okay? So if you want to refer this guy, initial reactant and reactant, all the way to 2, then you must need to multiply KF1 by KF2, like this. So, you know, this is different than KF2 alone, right? So now, that's why, for simplicity, this overall K is called beta 2. Beta 2, not beta, capital letter B2. Okay, beta is the tail is different. This guy goes first for beta, and B is this guy comes later. Okay, too much for Jeremy?
Yeah.
Yeah, I hope you feel better for the lab later. Okay. Okay, so this K is called B2, cap B2. So the 2 refers to this complex, okay?
That's only, the overall K is only for
Overall.
KF1 and K.
Yeah.
KF2.
Yeah, that's right. So this you can see overall, yeah, overall to get that from the beginning. So to be consistent, even though this KF1 represents this reaction already, but consistently, then well, I look at this as overall to that point. So it is B1. Okay. So following that, then B4 is just simply the overall to form the final product from the reactant. Okay, you multiply all the K's. So each individual K is quite large. K of formation is the magnitude of 10 to the power 10 or so. So you multiply all that, then that means as long as how should I say it, that a reaction will drive to the right, so it's going to be based on a limiting agent. Okay, the quantity is highly dependent on just the limiting agent because it goes all the way to the right. Okay, so the stability, the greater the B value, the magnitude, the more stable the product is, right? So you can relate to the relative stability of products. Then a final product will be quite stable. Notice the B4. Okay, now there will be some tricky questions, whether equilibrium concentration versus initial concentration in reaction. Those are different deals. So be very cautious. So look at this example now. Now this is a mixture containing zinc ion and ammonia. Okay, so you can use analytical instrument to realize the free quantity of that. So at equilibrium, so you analyze a mixture, you know the free concentration is this, is 0.0010 molar of that. So this is free at equilibrium. You also be able to tell the free quantity of ammonia to be of this concentration. So these two are at equilibrium. So now with this knowledge, calculate what will be the concentrations for all the complexes. Notice the complexes will be for ammonia 1, 2, 3, and 4. You know, those 4 complexes. Okay? For example, so this is a complex. What will be this concentration in a mixture? While knowing the 2 equilibrium concentration. So once you are thinking along this line, then this calculation is straightforward, right? So what's the problem? You already know the equilibrium concentration. Just plug in. Okay? And beta 1 is what? KF1, right? So you plug in that, so you can solve for this one complex concentration. So it's straightforward now, right? So that complex is equal to, the 2 is already given because you interpret it correctly. So you just go in with these 2 values. Then beta 1 is table value, which is KF1, is 186. So this corresponds to between zinc and ammonia system is 186. So you plug that in, then you get the complex 1 concentration to be this. Okay? So it's quite straightforward. So the second complex, right? The ammonia 2 complex, then you do a similar calculation, plug in the equilibrium concentrations. But be careful, ammonia now is to the power 2. Okay? Then the B2 is equal to Kf1 multiplied Kf2. So you end up with a concentration. So I trust you can do this, right? Similarly. So for beta 3, then the ammonia will multiply to the power 3. Okay? Then beta B4, then is ammonia equilibrium concentration to the power 4. Okay? So all that tricky things. So during an exam, stay calm, don't rush. So you know what to do under that condition. Now this one is a different condition, although appears to be similar, but it's different. Okay, so you're going to mix the two chemicals to form complex. So you calculate after mixing, then you know the initial concentration. So this will be an initial concentration. Okay, so you're going to start with this concentration of zinc, and you start with this concentration. So this is typical in carry out experiment. So here your knowledge is going to be limiting agent, okay? Because Kf values are huge. They drive to the right. The forward reaction will favor, so concentration will be based on the limiting agent. So now you're going to calculate different species concentration in a mixture, just like the previous problem. You got to calculate the complex, metal complex concentration. So you will need to calculate the equilibrium concentrations of all the species, equilibrium concentration of the thing containing species. Okay.